We are going to go ahead and start. So if you are taking Math 1314, you will stay in this room. If you are here for 1324, they are posting the link for you. And so throughout the session, if you have any questions, feel free to put it in the chat or raise your hand, and we will be happy to help you. So my name is Yvette Chuca, and Mr. Carizales will be working in the 1324 room. So for the 1314 or the 314 classes, you will be using Cengage WebAssign. And so there's two ways that you can register for your class. Number one, if your instructor provides you a class key, it's going to look something like this. Or your instructor might have given you instructions to register through Blackboard. And usually there's a link that you just click and then you can sign up. Okay, but once you enroll for WebAssign, if your instructor gives you the class key, then you would enter your class key here. And once you're in WebAssign, the good news is that you're not going to have to purchase an access code because that's part of your tuition already. So you can just ignore the if it's asking you to purchase something, you don't want to purchase anything because that's going to be part of your tuition already. To get to your course, you'll go ahead and click on courses, and then it's going to open up any of your courses. So if you're taking 314 and 1314, you're going to see both of your courses there. Once you have logged in, you can also change your password or add another email by clicking the arrow next to your name. Again, the courses is going to list all your Cengage products, even if you were using Cengage for a different course, let's say biology, it would list them here as well if you already have access to that. Now, some of us, we prefer to have like a printed textbook. So if you want to rent a printed hard copy of your book, there's some options here. You can click on rental options. Again, the ebook is already part of your access. So you can print out some of those pages from your ebook as well. And then from here, this symbol here just gives you other products that are included in your subscription. But once you get into the actual WebAssign course, some of these symbols up here are going to be helpful for some of us. So for example, if you prefer to have your things in Spanish, then you can just click this little circle and you can change your text from English to Spanish. And then you're gonna see, you see here, once I clicked it, it looks like this. And let me just go to the next one. This is important because for one, if you like to have reminders, this would be the place to do that. So here, for example, you can say, notify me if there's a due date change, like if your instructor changes the due date, or if your instructor posts an announcement, or if your instructor has given you an extension, or if they reply to your email, for example. And then it can also send you reminders. You can select the time, like give me 12 hours reminder for the due date or 6 hours, etc. So these are very helpful to, keep track of your assignments. And let's keep going. So here's where you'll find your ebooks. They'll be listed here. If you're taking 2 classes, you'll see the 2 books there. And communication, some instructors have this button turned off, but some of us have it on. So if you don't see the communication button, that usually means your instructor wants you to communicate through either Blackboard or through their Outlook messages. But if it's on, you can send an email here if it's available for you. And then we have the grades. If you click on the grades, you're always going to have your grades updated here if your instructor has set up the grade book. And that would be for grades that are only in WebAssign or any grades that your instructor might have inputted. And then last, your assignments will list all your assignments that are available for you. And then just to show you a few extra things, on the right side of the course, you're going to see any announcements that your instructor has posted. You also have something called Insights. You can click on this, and this is just going to give you insights on how you're doing and give you a chance to practice a little bit more. On the left side of the screen, you're going to see your assignments are listed. And then towards the bottom, you're going to see something called Resources. And so this tab here is if your instructor has made available, for example, the lecture videos of the book or the PowerPoints, they would be listed here, or any other resources that your instructor has provided for you. The other button that was here, the personal study plan, this is just an opportunity to get extra practice. It's not for a grade, and it's just for you to practice if you want to get extra examples. Now, once you're inside of your actual homework, you're going to see some symbols. So here we have the, let me just scroll down a little bit. So here you have a graded quiz. This means that you have a quiz, but in order to do this, you have to complete a different assignment with a certain grade. If you see a little computer with the asterisk here, it means that your quiz or your assignment has a password. And so your instructor is the only one that would be able to provide that. Then if you see this, that just tells you that this assignment is timed and how many minutes you have. And then some instructors have a lockdown browser. And so it's going to look like this with a little lock. And now inside of your assignments, it's going to list how many questions you have and then when it's due. But some of the questions have help buttons. So if you click the read it, it's going to open the ebook. If you click watch it, it's going to give you an example of the problem that you're working on. As your teacher is going to send your instructor a picture of the problem that you're working on in case you have a question about it. You want to click this and it'll tell us where your questions are. And then they also have a practice another version, so you can practice a couple more problems. Not all the questions have the same buttons, so it just depends on each question. So that was just a little glimpse of WebAssign. Now we're going to look at, excuse me, a couple of examples. So the first examples that we have here are from section 1.1. And these are examples for the distance and the midpoint formulas. So the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And these x2 and x1s are just going to be an ordered pair. And so I have it list them as x1, y1, x2, y2. And then the midpoint of the line segment that joins these 2 points can be found with x1 plus x2 and y1 plus y2. And so we're going to do a couple of examples. And so here we have find the distance between the points. So here are my 2 points. So the first thing that I encourage my students to do is to label these as x1, y1 and x2, y2. Or you can label it as x2, y2 and x1, y1. It doesn't matter which way that you label as long as they both have the ones or they both have the twos in that same order pair. Okay, so we want to go ahead and replace them. So here we have x2, which is -6, minus x1, which is 1. And then we're going to have y2, which is -2, minus y1, which is 5. So now we're going to simplify. So -6 minus 1 is -7. -2 minus 5 is -7. So -7 squared is going to be 49. And -7 squared is 49. So 49 plus 49 is going to be 98. So in your homework WebAssign, your answers have to be inputted as simplified radical, simplified as a simplified radical. So I'm going to tell you what that means here. If you were to enter this in your computer, it's going to count it wrong. If you enter a decimal, it's going to count it wrong. So why is it going to count it wrong? Because it wants a simplified radical. And so in order to simplify the square root of 98, you want to consider the perfect squares. Perfect squares are made up of just multiplying two numbers together, the two identical numbers. So 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, that's a perfect square. And this could be, this is infinite, right? So you can have 10 times 10, which is 100. So 100 would be a perfect square. And these numbers here, 4, 9, 16, 25, 36, 49, the reason they're perfect squares is because we can take the square root of 4, and that's going to give us a 2. The square root of 9 will give us a 3, and so on. So what you want to do is you want to look at your number 98, and you want to ask yourself, can I rewrite 98 so that I can use one of those factors as a perfect square? And so if we go to the next page, so 98 I can write as 49 times 2, and 49 is a perfect square. So the square root of 49 is going to come out as 7, and then 2 is not a perfect square, so it's going to stay in the square root. And then 2 can be simplified any further. So my answer would be D is equal to 7 square root of 2. So again, it's important, even though the computer does not specify to enter a simplified radical, you want to make sure that you simplify. And a lot of times students will get them wrong because they enter the decimal. Okay, so for the midpoint, we want to do the same thing. We want to go ahead and label our points, and then we're going to use the midpoint formula. Here's our midpoint formula. And we're just going to substitute this value. So x1 and x2 are 1 and -6. And then y1 and y2 are 5 and -2. So let's simplify. 1 plus -6 is -5. 5 plus -2 is +3. So we have -5 halves and 3 halves. Notice that my answer is an ordered pair because this is a point on the graph. Okay, so that's going to be your answer there. So now we're going to go ahead and continue with graphing equations. So we have point plotting method, x and y intercepts. So graphing equations, you're going to see in section 1.1, 1.2, 1.3, and basically almost every section will have some type of graphing. Okay, but for the first sections, it's on 1.1, 1.2, and 1.3. So the point plotting method is basically you want to pick some points for x. X is an independent variable. So you want to choose any values that you want for x. However, I encourage you to make sure that you use some negative numbers, positive numbers, and 0 for sure. The other thing that I encourage you to do is to use consecutive numbers. In other words, you don't want to pick 20 and 100 and 1000 because then it might be a little bit harder to see the actual graph and be able to plot it. Okay, so the best numbers that I like to use are some negative, so -2, -1, 0, and then 1 and 2. So this is our independent variable, so we're going to take -2 and we're going to plug it in for x, and then we're going to see what it gives us for y. So we have y is equal to -2. I'm going to plug in my x for x, so we get -2 here. -2, -2 is +4 plus 5 is equal to 9. So when x is -2, we get 9. So that creates our ordered pair, -2 and 9. Then we go to -1. We do the same thing. Substitute -1 for x, so -2 times -1 is +2, plus 5 is going to be 7. So my ordered pair is -1 and 7. And then we do the same for 0. So -2 times 0 is 0, plus 5 is going to give us 5. So our ordered pair, 0 and 5. And we keep going. And so we do the same for 1 and 2. We get the points 1 and 3 and 2 and 1. So your next step is once you have your ordered pairs listed here, then we're going to go ahead and plot the points. So we have -2 and 9. So that's -2 and 9. Then we have -1 and 7, and then we have the rest of the points. Now on your assignments in section 1.1, the instructions say plot the points. So that's all you have to do is plot each of the points, and then that's your answer. So you want to make sure that if it says plot the points, then this is your answer here. But if it says to graph the equation, okay, so graph the equation means that you want to actually connect your points with the line. So in the tools, you'll be able to select a line. You want to select the line that has the two arrows, and then it's going to connect your points. Okay. So again, plotting the points is just the points. Graph the line means to connect it with the line. Let's try another one here. So we have y equals 5 minus x squared. And so I just to save a little bit of time, here's the work. And then these are our points. Now, if you want to download the PowerPoint, if you see my arrow here that I'm moving, right on top of that, you should see a box with an arrow pointing down. And that's going to allow you to download the whole PowerPoint so that in case you want to come back later, you can look at this a little bit with more time. Okay, but here are my points. And so if I plot those, here's my points are plotted. But now I need since the question says to graph, I need to connect the points. And so this is going to be a parabola. And so this is what the graph is going to look like. Okay. And so this slide should have been the first slide. And so, but this is what we covered, right? So we did point plotting and then we graphed the equations. So those were the 3 sections. Now there's going to be other ways for us to graph as well. A second method is X and Y intercept method. And so first let's talk about what is an X and Y intercept. So if you have a graph, the x-intercept is where the graph crosses the x-axis. So this horizontal line right here, this is called our x-axis. And then this vertical line, this is called our y-axis. So the x-intercept crosses the x-axis. And then the y-intercept is going to be where the graph crosses the y-axis. But what I want to highlight here is that in the x-intercept, notice the value of the y is always going to be 0. And for the y-intercept, the value of x is 0. And so if we want to find the x-intercept, then we always let y equal 0 and solve for x. If we want to find the y-intercept, we let x equal 0 and solve for y. If they give us a graph, we can just look at the points, but we don't always have a graph. Okay, so for example, if we want to graph this using the x and y intercept, here's my equation, y equals negative 2x plus 5. I'm in the x-intercept, so I'm going to let y equal 0. And then I'm going to solve for x, so I'm going to subtract 5 on both sides. And then I'm going to divide by negative 2. So I get x is equal to 5 halves. So this is my x-intercept. And then for the y-intercept, I'm going to write my equation. And now I'm going to let x equal 0. So y is equal to negative 2 times 0 plus 5. So 0 times negative 2 is 0, plus 5 is going to be 5. So when x is 0, we get 5. Now that we have 2 points, if you're graphing a line, later on in the semester, you're going to be able to, excuse me, you're going to be able to see an equation like this, and you're going to be able to say, okay, I know that's going to be a line. Or you're going to say, oh, I know that's going to be a circle, or I know that's a quadratic function, it's a parabola, etc. So in 1.6, you'll learn about why is it a line, why is it quadratic, why is it a circle, etc. So for now, this is going to be a line. And whenever you have a line, all you need is 2 points to graph the line. So the 2 points here that I use were the intercepts. And so if I plot the points, we have 0, 5, and then we have 5 halves and 0. Now, when you're graphing this on the computer, you want to estimate where 5 halves is, which is about 2.5. But notice that it's really hard to see if that's 2.5 or not. So once you plot your point close to it, on the right side of your screen, there's going to be a little table that opens up. So you can find your point, 2.5 and 0. And instead of leaving it as 2.5, go ahead and write it as a fraction, 5/2, so that the computer can identify the exact location of 5/2. Okay, so if you leave it as a decimal, it might count it wrong for you. To be more accurate, once that window pops up, go ahead and change it in there. But now that I have my 2 points, I connect them using a line. And so this would be my answer for the graph. Okay, so now we're going to look at writing equations of a line. This is from section 1.3. And so first, a line, you know something is a line if the highest exponent of x is a 1. And so, for example, if you had, let me just draw something here. If you had something like this, y is equal to x plus, let's say, x squared, and then let's say plus 3. If you look at this equation, the highest exponent for x is not 1, it would be 2. So since the highest exponent is a 2, then this equation is no longer a line, okay? So in order for it to be a line, the highest power of x has to be a 1. Now for lines, there's 3 ways we can write the equation. We have the general form, which looks like this, ax plus by equals c. We have a point slope form, which is y minus y1 equals m times x minus x1. And then we have the y-intercept form, which is y equals mx plus b. Now, if your equation is set up as the y-intercept form, then the number in front of x, which is in this case m, that's going to be your slope. And slope tells you how steep a line is going to be, okay? And so then b is going to be your y-intercept for that equation. But the line has to be in this form in order for you to identify the slope and to get the y-intercept, okay? Now, if you know the slope and you know the y-intercept, then you can always write the equation. And we'll do some examples here. So it says writing equations of a line, write the equation of a line with slope 4 and y-intercept 5. So what you want to ask yourself is, do I know the slope and do I know the y-intercept? And in this case, we know both. And so what we just need to do is I'm going to use the y-intercept form of a line. And I have y is equal to my slope. In this case, they tell me it's 4. So I'm going to replace m with 4. And they tell me my y-intercept is 5. So my answer is y equals 4x plus 5. And that was it. Okay, and we were able to do that because we know what the slope is and we know what the y-intercept is. Let's try this one. Write the equation of a line with slope -2 and passes through the point 0, -4. So in the previous example, they straight out told me that's the y-intercept. But over here, they don't say that. But do we know the slope? Yes. Now we look closer at this point here. This is a special point because x is 0. That means that -4 is going to be my y-intercept. Okay, so we do know the slope and we know the intercept. So the slope is -2 and the y-intercept is 0, -4, which can translate as b is equal to -4. I'm going to use my y-intercept form of a line and substitute the values. So here we get y equals m is -2, and then b is our -4. And so that's going to be our answer. Of course, they don't always make it that easy for us, right? So let's try some that are different. Write the equation of a line that passes through the points 1, -3, and 0, 4. So here we ask ourselves the same questions. Do we have the slope? They don't tell me what the slope is, but they give me enough information to find the slope. Okay, so in this section, you're going to see a formula for slope. M is equal to y2 minus y1 divided by x2 minus x1. And so again, you can label your points x1, y1, x2, y2. We're going to plug those in. So in our example, we have y2 is 4 minus y1, which is -3. x2 is 0 and x1 is 1. So 4 minus negative 3 is the same as 4 plus 3, which is 7. And then 0 minus 1 is negative 1, minus 1 is negative 7. So my slope now is negative 7. And the y-intercept, let's look at our points. I see that x is 0 here. So that means that this point is my y-intercept. And so now we can plug in our information. So my slope is negative 7 and my y-intercept is 4. Okay, so that's my solution. Let's try a different one. Okay, so kind of similar to the other one, right? Do we have a slope? No, but we can find it using the slope formula. So we're going to have y2, which is 4, and then this should be 0. So let me go ahead and just write that. Let's do it here. Okay, let me just write it over here. So we're going to have y2, which is 4, minus y1, which is 0, divided by x2, which is negative 1, minus x1, which is 2. So we end up with 4 minus 0 is 4, and negative 1 minus 2 is negative 3. Okay, so this is incorrect. And then the next question is, what is the y-intercept? So in a little bit, somebody remember negative 4/3, because I think the next slide is going to be incorrect too. But what is the y-intercept? If we look at this point here, 2, 0, since x is not 0, this is not your y-intercept. This is your x-intercept. Okay, so this is not your y-intercept. So we need to go ahead and do the work here, right? So let's see, what was the slope? I think it was negative 4/3. So that was 4. And then correct me if I'm not right, but I think it was negative 4/3. Okay, so now you know your slope. So now the problem here is we don't know the y-intercept. Since we don't know the y-intercept, we're going to have to take another step, okay? And so we can use the point slope formula. And in this situation, you want to pick either this point or this point. So I'm going to go ahead and pick this point here, 2, 0. And so here I'm going to have y minus y1, in this case y is 0, is equal to my slope. Hopefully it's the right slope, because I don't remember. And then x minus 2. I guess let me just work it out again just to make sure. So we get 4 and 3. Okay. So now you want to simplify. So y minus 0 is just going to be y. And then we're going to substitute negative 4/3 or multiply it across. So we get negative 4/3 x. Negative and negative is positive. And negative 4 times 2 is 8/3. Okay. So this would be our answer, 8/3. So now you can use the point slope form, or you can use y equals mx plus b. If you use y equals mx plus b, it's going to be the same idea. In this case, y is 0. Again, I'm going to use this point over here, the 2, 0. M is negative 4/3. And then x is 2. And then we have plus b. Okay. So negative 4 times 2 is negative 8/3 plus b. Okay. So negative 4 times 2 is negative 8/3, and then we have plus b. And so essentially, if you use that, you're looking for b. So b is going to be equals to 8/3. And now you just plug it in. So y is equal to your slope, negative 4/3 x, and then plus b, which is 8/3. And so we end up with the same answer. Okay, so let me go on to the next slide. And then, so again, like I mentioned here, we pick a point. So I picked 2, 0. The only problem is I left the wrong slope. So that's why I worked that out in the previous page. So let me just keep going. All right. So now we want to do the same idea, but now they tell us that the line that we're looking for is parallel to this line. Okay, so they want us to find an equation that is parallel to this line that passes through this point. So visually, let's see what that means, okay? So this y equals negative 2x plus 4 is this line that I'm displaying here. And then the point is negative 3 and 4. So parallel means that the lines will never intersect and they're running right next to each other. So what we're trying to do is find the equation of this line that I drew here that passes through the point negative 3, 4. If the lines are parallel, they're going to have the same slope. Okay, so in this example, the slope of y equals negative 2x plus 4 is negative 2. And the only thing we know about the other line is that it passes through negative 3, 4. But since they're parallel, that means that we're going to use the same slope. So I can say that m is equal to negative 2 is going to be the slope here. So now that we know the slope, negative 2, and we know it passes through negative 3 and 4, then we can use the point slope of a line or the y-intercept form. Okay, so I'm going to use the point slope here. So we have y minus y1. Where are we going to get this y1 from? From the point that they give us. So the point they give us, the y is 4. So I'm going to substitute 4. M is the slope. So I know that the lines are parallel. That means that we're using the same slope as the given line. So our slope is negative 2. And then we have x minus x1. x1 is coming from that point that they give me, negative 3. So if we simplify, negative negative here is positive 3. And then we're going to go ahead and distribute the 2, the negative 2. So negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. And then we're going to add 4 on both sides. So we get y equals negative 2x minus 6 plus 4, which is y equals negative 2x minus 2. So that's going to be our equation of the line that is parallel to that other line. Okay. So now the word perpendicular, what does perpendicular mean? That means that the lines do intersect, but they intersect forming right angles. Okay. So there's a difference. Some lines intersect, but they don't form right angles. So a right angle means that this angle where they intersect is 90 degrees. And so what we're looking for is this red line. And so if the slope of the given line is negative 2, to find the slope of the perpendicular line, it's going to be the negative reciprocal of that line. So perpendicular lines have negative reciprocals. What does that mean? Basically, you want to flip the numbers. So if you have a 2, you flip it, you take the reciprocal. And so the reciprocal is a half. And then if your number was negative, then you're going to have a negative of a negative, which is going to be positive. And so you're basically changing the sign. So if it's negative, you're going to end up with positive, and then you flip the fraction. So now we have 1/2. So if we want to find the perpendicular line, we're going to have a half is our slope, and then we have our point, and then we do the same thing. So we plug in y minus 4, 4 coming from the point. Our slope is a half, and then our x is negative 3. Simplify, so we get, let's multiply a half in parentheses. So we're going to end up with 1/2 times x is a half, and 1/2 times 3 is 3/2. Now we're going to add 4 on both sides. And then in order to add 3/2 and 4, I'm going to have a common denominator, which is going to be 2. So 4, we can rewrite it as 8 divided by 2. And now that they have the same denominator, I can add 8 plus 3. That's going to be 11/2. So this would be the equation of that perpendicular line. Okay, so what you want to remember is parallel. You use the same slope. perpendicular, you use the negative reciprocal. Then once you have that information, then you can use the point slope form or the y-intercept form. Okay, so that was examples from 1.3. 1.4 is evaluating functions. But I guess the big question is, what is a function, right? So a function from set A to set B is a relation. A relation is just a set of ordered pairs. So like this is a set of ordered pairs. And in this relation is a relation that assigns to each element in set A exactly one element in set B. And that's the key word here. Set A, exactly one element in set B. The set A is the domain or the set of inputs, and then the set B is your range, which is your set of outputs. So whenever you're dealing with domain, you're looking at all the basically the x coordinates if you're working with x and y, and the range is the y coordinate. Okay. So we can represent functions as ordered pairs. That would look something like this. A graph, which is a graph, right? I'll show you some in a little bit. Or an equation, they might give it to you like this. Okay. Now, in order to determine if something is a function, then it should meet these criteria here. Okay, each element in A must be matched with an element in B. Some elements in B may not be matched with any element in A. So everything in the first set has to be matched in the second set. But if the second set has extra points, it doesn't have to be matched. And then two or more elements in A may be matched with the same element in B. And then an element in A cannot be matched with two different elements in B. And number 4 is the big one that tells you if this is not a function or not, if it's a function or not. So let me just give you an example here. So what I like to tell my students is basically these are your domains, these are your range, and what you want to ask yourself is the number -2, is it matched exactly with one number in the range? So does -2 go to only one thing on this side? And so we can see here with the arrow that -2 goes only to 3. So that's a good thing. Now we go to -1. -1 is going to 3, but it's also going to 4. So -1 is going to two different things in the range. And so because it's doing that, it's not meeting this last characteristic. Okay. So it's going to two different things. As soon as you see that happen, it makes this not be a function. Okay. 0 goes to one thing, 1 goes to number 5, which is only one thing, and 2 goes to just one thing. Even though 1 and 2 are going to the same item in the range, that's okay. The only time that it's not okay is if -1 goes to two different numbers in the range. Okay. So for that reason, let me just keep going here. For that reason, this is not a function because -1 is going to two different values. Okay. Now we look at letter B. It's given to us in a table. So for some of us, this might be a little bit harder to see. If that's the case, then there's no problem. We can rewrite it, right? So you can rewrite it. So all your X, they tell you it says input. That means that these are all in the domain. So I'm just going to list them vertically 0, 1, 2, 3, 4. And then my output is my range, -4 to 0 to 4. And now I can see that 0 goes to -4. So I'm going to represent that with an arrow. And then 1 goes to -2 and so on. Okay. Now if I look at each one individually, does 0 go to only one thing in the range? Yes. Does 1 go to one thing in the range? Yes. Does 2 go to just one thing over here? Yes. Does 3 go to one thing? Yes. And 4 goes to one thing. And so that makes it a function. I don't think I wrote it. Yeah, it makes it a function. Okay. let's look at a different example. So this is coming straight out of WebAssign. Which sets of ordered pairs represent functions from A to B? Okay. So here we have our A. This is 2, 3, 4, 5, which is the domain. And then B is our range here. So you want to look at each one and ask yourself, is it a function? Is it not a function? Okay. So if it's helpful, again, you can draw. Let me just draw letter A here. So we have my domain. So the first numbers make your domain. So 2, 3, 4, and 5. And then our range are the second numbers, 1, -2, 0, and 2. So 2 goes to 1, 3 goes to -2, 4 goes to 0, and 5 goes to 2. Okay? So are each of those numbers going to exactly one thing in the range? And the answer is yes. So therefore, this is a function. But now let's look at letter B. So same thing, the domain is 2, 3, 4, and 5. And then the range, they only give me 0. Okay? The rest are zeros there. So this 2 goes to 0, 3 goes to 0, 4 goes to 0, and 5 goes to 0. So again, the question is, does the number 2 go to just one thing in the range? Yes, it goes to 0. 3 goes to 0, 4 goes to 0, 5 goes to 0. So they're each going to just one thing in the range, and it just happens to be the same number in the range, and that's okay. Okay, as long as the number 2 does not go to a different value. So this still makes it a function. Now this one that I'm going to draw is not part of this, but I just want to make sure that we're understanding. Let's say this is 0 and 1 here. Let's say that 2 to 0 and 2 goes to 1. Now 2 is not going to one thing, it's going to 0 and it's going to 1. So this would be not a function, okay? So I just wanted to add that one in there so that we can see the difference. Now the last one, letter C, I'm going to draw it up here. So we have domain, we have 2, 5, 3, and then the range is 2, 0, and 1. So 2 is going to 2, 5 goes to 0, and 3 goes to 1. So by looking at this, we might want to say that it's a function, right? But it's actually not a function, okay? And you might be wondering, well, why is it not a function if each one of those elements is going to just one thing? It should be a function, right? But why are you telling me that it's not a function? The problem with this number is that this is your domain. All the values in the domain have to be used, okay? The range doesn't matter, but all the values in the domain have to be used. So in this example, we're missing the number 4. Since 4 is not being assigned to anything, then automatically it's not going to be a function, okay? And so again, just remember in the domain, all your values have to be used. In your range, it doesn't matter. Okay, so now let's continue. Now, if you're given a graph, let me just draw a graph. Let's say I have a circle and a line. Then you can use the vertical line test to determine if it's a function or not. If you draw a vertical line on the graph and it only touches your graph in one spot, then it's going to be a function. Okay. But if you draw a vertical line and it touches in 2 locations of the graph, then it's no longer a function because For this x value here, you get 2y's. Okay, so this is not a function. Okay, so that was using a graph. But now what we want to do is evaluate functions. So let's say you have this function, f of x is equal to the square root of 3x minus 2. And you want to know if x is 2, what is your function going to give you as an output? So anywhere you see an x, you're going to replace it with the number 2. So here I see an x, I'm going to replace it with the number 2. And then we're going to simplify. 3 times 2 is 6, 6 minus 2 is 4, square root of 4 is 2. And so what that does is that when x is 2, y is going to be 2. When you're evaluating functions, you're basically getting ordered pairs, an x value and a y value. What if x is equal to a? Again, we still do the same thing. We replace x with a. So here's an x, I'm going to replace it with a. Then we simplify. 3 times a is just 3a minus 2. There's nothing else I can do to simplify, so that's going to be my answer. And then letter C is 6 plus h. So everything here is going to replace x. So if my x is right here, I'm going to have 3 times 6 plus h minus 2. Then we want to simplify. 3 times 6 is 18. 3 times h is 3h. And then we have our minus 2. 18 minus 2 is 16 plus 3h. So that's going to be our answer here. This is called the piecewise function. And the reason it's called the piecewise function is because the function, this is called the piecewise function. And the reason it's called the piecewise function is because the function is broken up into 2 pieces. And then this on the right side are the conditions. So basically for any value that is x, for any value of x that is less than -1, we would use this equation. And any value that is for x that is greater than or equal to -1, we would use the second equation. So the first thing you have to decide is which piece are we going to use. So if x is -4, does it fall in the first equation or does it fall in the second equation? So -4, is it smaller than -1 or is it greater than -1? Okay, so that's what you want to ask yourself. So -4 is smaller than -1. So we're going to use this first equation. So I'm going to have f of x is equal to -2x minus 2. Wherever I see an x, I'm going to replace it with a -4. -2 times -4 is +8. Minus 2 is going to be 6. Now this one has -1. Well, if x is equal to, that's what this one means, right? Greater than or equal to -1, then we're going to use the second equation. And so now anywhere I see an x, I'm going to substitute it with -1. So I have x squared, so I'm going to have -1 squared plus 2 times -1 minus 1. -1 squared is 1. 2 times -1 is -2, and then we have -1. 1 minus 2 is -1 minus a 1, -2. And then the last one, f of 1, well, 1 is greater than or equal to -1, so we're going to use that same last equation. So anywhere I see an x, I'm going to replace it with a 1. So we get 1 squared is 1, 2 times 1 is 2, minus 1 is going to give us 2. 1 plus 2 is 3, minus 1, 2. Now the last part, which is we have about 10 minutes left. This last part is actually something that I like to tell my students. If you can understand the domain and range right away in the course, then it's going to help you in every chapter that we have after that. Okay, so hopefully we can look at that. So let's see the domain of a function and what that is. So the domain of the function is all the x values that are being used to make this graph. Okay, so for example, if we look at this graph, and if I pick any x value, let's say I pick 5, does it help me create this graph? Well, if I go up, Does it touch the graph? And the answer is yes. So 5 is part of the domain. If I pick this number and it goes up, it also touches that graph. And I can do this for any x that I have here, right? If I pick -5 and I go down, it touches the graph, and so on. Okay. Well, what if I pick, let's say 20, that's over here. And if I keep going up, in my view, I cannot see that it touches the graph. But the arrow in this graph tells me that this is going to go on to infinity and it's going on forever. So eventually, this point 20 is going to touch this graph. Okay. So all these x values are being used to create my graph here. Okay, so we're going to talk about, so that would be your domain. So your domain would be all these x's are being used. Okay. But we don't always have a graph. So when you don't have a graph, then you want to ask yourself these questions. Does the equation have a fraction such that in the denominator it has a variable? If that's the case, then there's going to be some restrictions. And what do I mean by that? Let's say you had 1 divided by 2x. Okay, notice that there's a fraction, and inside and the denominator, which is the bottom part, has a variable. So since you have a variable in the denominator, that means you're going to have some numbers that we cannot use because we cannot divide by 0. So for example, if x was 0 here, we would have 1 divided by 0. And if you put that in your calculator, for example, it's going to tell you that it's an error or undefined depending on your calculator. Okay, now if you have square roots or even roots, then there's going to be some restrictions. So like if you have the square root of x, it's going to have restrictions because we cannot take the square root of a negative number. Okay, and then the last one, which you don't have to worry about till you get to chapter 3, does it have a logarithm? And if it has a logarithm, then that means that there's restrictions. But if you're able to say no to these 3 questions, then the domain is always -infinity to +infinity. So let's do some examples. So the first one, y equals x plus 5. Does this equation have a fraction with a variable in the denominator? The answer is no. Okay, so that's your first question. Does the equation have a square root or an even root with the variable as a radicand? The answer is no, there's no square roots here. And then the third question is, does the equation have a logarithm? You're going to know if it has a logarithm because it would have the word log next to close to the x. So there's no log in here. Notice how I said no to all 3 questions. Therefore, my equation is going to be, or my domain is going to be -infinity to +infinity. When you're working with infinity, we use a parentheses because we don't know what exactly that number is. So we use a parentheses. When you want to write your domain, your smallest number always goes first. Okay. Now, if I was to graph this line, then notice that this is a line, and I'm going to be using all these x values. Okay. Let's look at the next one. So for this next one, let me just take it away here. The questions: do you have a fraction? No, there's no fractions. Do you have a square root? Sometimes some students will say yes because they see the square, but that's a square, it's not a square root. Okay, so the square root, you want to make sure it's you're going to see this symbol. Okay, so this equation does not have a square root and it doesn't have a logarithm. So the domain is -infinity to +infinity because I don't have any restrictions for those 3 conditions. If you were to graph it, then it looks something like this. And you can see here that the x values, we're using all these x values in here, right? All these x values. But even if I was to pick an x value over here, this graph is going to keep going on forever, and eventually this x value will be used to create that graph. Okay, so let's go on. Now we start getting a little bit more interesting, right? First question, do you have a fraction? And yes, I have a fraction here. Okay. As soon as you see a fraction with the denominator having a variable, then that should put some flags up. That means you have some numbers that you cannot use as part of the domain. We call those restrictions. And so basically you want to ask yourself what numbers would cause me to have a 0 in the denominator. If you're not sure by looking at this, it's okay. What you want to do next is set the denominator equal to 0 and solve for x. So your domain is going to be, you can use all the numbers in the world except for 0. We cannot use 0, okay? So the way we would write it is it's going to go from all real numbers except 0. In interval notation, it's going to be all the negative numbers, and then you get to 0. I'm going to use a parentheses because 0 is not included. We use brackets if it is included, but in this case, it's not included. So we use parentheses. Then we're going to have this symbol. This symbol means union. And then it starts again at 0 to infinity. Okay, so what that means, if I had a graph here, here's a number line. Here's a number line. And let's say this is 0. It means that you can use all these negative numbers and then all these positive numbers. So you might be wondering, why do I include 0 though? Well, there's so many little close numbers in here that we can't really see. So we just put 0 to make it include all those little numbers. Now the next one, x minus 6. Do we have a fraction? So we're going to take this part of the denominator and we're going to set it equal to 0. So x minus 6 is 0. If I solve for x, I get x equals 6. So notice if x is 6, then you get 6 minus 6 is 0, and we cannot divide 3 divided by 0. So your domain is going to be everything except for 6. So the domain is all real numbers except for 6. So again, it's from negative infinity to 6, and then from 6 to positive infinity. Okay. And then that's just the graphs so that you can see what they look like. Let's do probably one more because we're running out of time. So the next one is y equals square root of x. Does this have a fraction? No, but it has a square root. Okay, so to find out the domain, you take the radicand, which is what's inside the square root, and you set it equal or greater than or equal to 0. And now this is where the domain begins, okay? So the way we would write it is you can use 0 to infinity. That's your domain. But you cannot use the negative numbers. Let me see if I have the graph. No, I don't have the graph. Okay, the graph for this looks like this. So you have a graph. Oops, and it goes like that. So you're using all these x values, but you're not using these negative numbers, okay? So now notice that I use a bracket because I am including 0. Now the last one for today, x plus 5, we're going to set it equal greater than or equal to 0. We're going to subtract 5 on both sides. So the domain is going to start at negative 5 and it's going to go to infinity. There's a couple of slides that are left. So if you want to click on the download button, which is right above here with the box point with an arrow pointing down, the rest of these slides are basically how to find the domain and evaluate it using a graph. And so I encourage you to download it. Now, the other thing I wanted to share with you before we hang up is in my, I have a YouTube channel. You can just look it up with Yvette Chuka. There's 2 accounts. One, you'll see some little kids. That's my personal account. But you'll see one that is like math related. And the reason I'm giving you that is if you want more specific videos on each of these sections, you can find them there in the YouTube channel. but also our friends here from Student Services, they have also provided a YouTube channel where all these presentations are being held for you. And so you can also go back to this recorded presentation if you want to go through it again. Okay. So I want to thank you for being here. Next week, we're going to do the same thing, but with the sections that are going to be due. And again, if you have any questions, you can stay here and ask us. And I'm going to pass it over to our lovely friends from Student Success Services.
Okay, thank you, Ms. Chuka, for that wonderful presentation on linear equations, domain and range, and graphing. Next week, we will be reviewing for Math 1314, we'll be doing combinations and composite functions, and for Math 1324, it'll be exam 2 review. So I hope that you all join us. Thank you for being a great audience. And remember to check out the presentations on our YouTube channels for the past presentations and then this one also. So thank you very much and have a great weekend.